route dampening. Doing that apart. There are two words. One is route dampening, the other is route flattening. So this is a problem, and this is a solution to it. Okay, so let's first explain this problem. As I mentioned earlier in the discussion, that I'm this AS, let's say AS100. I'm connected to another AS200, and this is announcing a network to me, some network here. This is announcing to me, but this network may have two kinds of problems. Sometimes it is available, or not available, and attribute which I'm interested in, attributes either this is there or it will be available. So let me write it. If available, attribute values or cost changes back and forth. So I have a network which I learned. So this is my home. This is my neighbor or external peer. This is my BGP link. So AS200 has sent me a route of n dot n dot n dot n, and it has two kinds of problems. Sometimes it's available, sometimes it's not available. Or it would, if it would be available, it would keep on changing the attribute or keep on changing the cost. If this is the case, then I'm having a route which is flapping. And this is a problem. Why? Because I may be a neighbor on this side. I may be a neighbor to a big network, right, on this side. And I learned N from external route, and I pass it on to the rest of the other ASs which are connected to me. So if that route flaps, my credibility is also at a stake, because then my neighbor would say, oh, we learned that route from this, which was an external route, and that is flapping. So BGP does not like the routes which flap. It's a route should be consistent and reliable. So route may flap with availability, non-availability, available, not available, one flap. Okay. For example, I give you an example of flap. It's a sort of a unit. Okay. For example, if I withdraw, so not available means what? BGP withdraws a route to, for example, a prefix and then sends an triggered update that and is available again. If I do that, that will be equal to one flag. So I was working, I withdraw NNNN, and then after a while, I said, oh, no, it's available. I sent a triggered update and I said it's available. So that would consider one flag. So if you do like this, similarly, another example would be, I was having a route available at a cost of this. And after a while, I said, let's say, I'm just saying, the other example is, I'm just using a rough parameter. So let's say the cost is 5 originally, down to 2, again to 5. So I will also consider this as one flag. But this change in cost or some other parameter is a flap of less serious nature as compared to a flap of availability and non-availability, because I can still reach it. So these are two types of flaps. One is like the worst one, the other is like, sort of less worst. It also has its own RFC. The road dampening, road flapping, it is 2459. So that is the RFC. Okay, so then how we deal with that? Now I'm going to bring in the perspective of route dampening. So in dampening, what we do is, we kick out that route temporarily. So we block that route temporarily, and that is the solution. How we do that? I give you an example. How that implements. Maybe a double N here. So let me draw a diagram. Let's say I had, so when I say kick out, so it means that route will not be advertised. Right? So kicking out means, this means no advertisement. I ever use black. So that means no advertisement for example, that prefix. Right? So neighbor, if I'm 100, if it was 200, it is flapping anyway. What I would do is I will not advertise it to the others. So that's what was my problem. I don't want to tell others about a route which is available, which is not available, which whose cost is changing or other attributes are changing. So what I do is I have a green zone. For example, if I want to show it with a graph, and I am having sort of what I should draw. So here I would say I can have, how I write it, I can have on this side permission, so less space. Let me put it a little bit. So permission, and on this side I have penalty. So on this side is penalty. If I go up to one limit, I would call it. So here I'm having reuse limit. So what I do is I implement a penalty system, and if a route flaps, I give it a penalty. For example, if a route becomes available, non-available, I give it a penalty of, let's say, 1,000. And if I have route flap due to a change in attribute or change in cost, I give it a penalty of 500. As I said, it's less disruptive, so I give it less penalty. So then I have a green zone, then I have a red zone. In my green zone, that is defined on my penalty scale by reuse limit. And reuse limit, for example, is let's say 1,000 or 500. So, I mean, usually the default is 750. They would say it is 750. So if I'm doing 750, my score as a route is 750. Let's say I go a little bit above. So at this particular time, I go a little bit above. Once I go above, then I cannot come back to reuse limit instantly. So I would be having sort of, if I want to come back to my previous limit, so I will be decaying like slowly. So I come back, and next time I flap another route, and I may hit another line on penalty scale. Let's say this is a red line. So I move, I flap again, and from there I got more penalty, and I reach up to a stage where my penalty went above this red line, which I would say suppress limit. So this limit is suppress limit. Suppress limit. Oh, I should put one other P. Yeah. So this is suppress limit. So suppress limit is again a numerical value. Let's say it is 2,000. And there was a route, route N. Let's say it flapped based on parameter. I flapped one time, I got 500 added. So 750. So 750. 750 plus 500, it will be 1250. I'm still below 2000. I flap once more. Let's say I'm here. I flap one more. Based on that, that goes to 1750. I reach somewhere here. And I flap once more. And I'm getting more penalty. And I go to 2250. When I go to 2250, so excuse me, my scaling. So what I will be sitting somewhere on top of 2000. As soon as I go on top of 2000, then I hit here two regions in this example. I will be having this region. As soon as I cross the suppress limit, then I enter another region on this permission scale. And I enter this region beyond this point. Beyond the point I crossed the suppress limit. So what it would do is I am allowed to advertise here. So here, no advertisement. And here I can advertise. So in my example, this is showing the character of AS200. Oh, sorry, no, AS100 is not. AS100. Right. So AS100 will keep on advertising N from AS200 if my penalty score is less than 2000. If my less than 2000, less than 2000, this point. So this is my, in this example, make and break point. So till here, I am less than 2000, right? So after here, I go, after this point, my value. So if I'm here, my value is here, right? Here, which is above 2000 after this point, okay? If that case happens, then I will suppress. That's why it's called suppress limit. If I cross that limit, then I would suppress the advertisement of that route, which is creating a problem. So it doesn't matter whenever I go, it doesn't mean that once I go, will I be suspended forever? No. So what I do is once I go back, if I want to go back. So if for a certain time I would not flap, then my penalty would be taken back. So as I moved up in sort of steps of 500, right? In 3 steps of 500, right? But when I will be moving back, for example, let's say after a while, I have, okay, let me put another color. So if I go up, I will always be always sort of coming back in a decay fashion. Let's say I decide I'm coming back in a decay fashion, but again, I flapped again and I went up again, right? And the 2000, I flapped again and I'm sitting at 500 now, 2500. So I am decaying. I may keep on, I become a stable route, and that would be mentioned or shown by this decaying pattern. And I'm stable and stable. If I'm stable for a certain amount of time, then I would decay till I, for example, may reach at the reuse limit. Okay. So so when I get jumped up, I just get added on. But when I come back, they would observe me for a longer time and they would let me come back slowly. So when I'm adding, I'm just adding 500, 1000 kind of those penalties. But when I come back, they would watch me for a time and then they would decay me slowly on this scale. So with this, what we do is, if there's a route which is flapping for either being available, unavailable, or due to the change in attribute or cost, I will like to watch it on the penalty scale and I will disable it. I will suppress it. I would not advertise it. I would not consider it reliable. And if once it has become reliable and it is reliable for a second, I would not say, oh, it is good. No, I would watch it longer. That's what is represented in this that is what represented with this sort of decaying behavior. What my bottom line is, I do not want my networks to be involved in speaking out those rules to my peers, which are not reliable, which are not stable. So that's why this penalty system is there, and every router sort of implements it, which I tried to explain. So you can add in bumps of 500 or 1000, but you would not minus them and jump down in a minute. You would be observed for a long time, as in this decay says. So with this, then let's look at the factors. Let's look at the factors. What are those factors or variables? What are those factors or variables that control this process? This process of putting penalty and kind of those things, what are those which they use, right? So there are three things in there, and they are shown as the part of a formula. So I write down the formula, and then I explain those three factors. So those factors, they are part of this formula. So I may have a maximum penalty. And that maximum penalty is equal to reuse limit. I already mentioned reuse limit to you guys. And then I will have this part of formula multiplied by 2. I will have maximum suppress limit. So as a network administrator or network engineer, you can tune in all those parameters. So in line with your routing policy, so you can tune all those parameters. They have some default values, but you can change them. So the third parameter in this case would be half-life. Time of half-life. So I want to see what is the maximum penalty, which is as a result of route flapping. Then I would say there are three things which would define it: reuse limit, maximum suppress limit, right? Suppress limit, I showed you maximum suppress limit. You would decide what would be your maximum suppress limit, right? And then half time. What are these parameters, right? So for example, half time is a settable parameter. And by default, it is sort of set up to 15 minutes. But you, as a network engineer, can change it. Reuse limit, I told you the reuse limit, what it is. It also has a default value of 750. It's a numerical number, it's a scale. And then you have a suppress limit. Again, a parameter, which is sort of a numerical scale, has a default value of 2000, and you can change it. Then what is my maximum suppress limit? Now, this is again in time. It would be 60 minutes. So if I reach the press limit, I will be blocked from advertisement. Myself, NNN, will not be advertised. For how long? It would not be. I have a maximum suppress limit. Okay. So what maximum suppress limit would be a function of? Function of what half time you use, what reuse limit you use, or what is your maximum penalty there, right? So all these four parameters, they can be calculated from each other depending what is given, right? So, and as I mentioned, I have not written, but I can write. So I can get a flap, a full flap. For example, a full flap can add a penalty of 1,000 points. And let's say a flap due to attribute change can add maybe 500. So that's how, if I have a reuse limit set up, if a flap happens, I will add it. And this suppress limit tell you, which could be up to 60 minutes, why I have a decaying factor, because I'm put off for a while and then I'm watched. And then I can come down on that scale if I show a consistency in there. How we configure it? So when I'm configuring BGP, I will say BGP, and I will use the keyword dampening. And then I will use these three. So where these terms are related with the software or the protocol, so then I will use these three limits. 1, 2, these three. So what are those three? These three. So I would say, what is reuse limit? What is maximum support suppress limit? And what is the half time? And then automatically, BGP software, it would sort of behave like this graph, right? As a function, it will behave like this graph. So you would say just BGP dampening and three parameters which are in the formula. And based on that, it would give a maximum penalty, and it would decay that penalty over time, depending on whatever the parameters you set up as network engineer, or if you use default. And when it's doing, it is sort of implementing this diagram, which I explained to you. Then I